Hello and welcome to this clip looking at how to determine the molar mass of carboxylic acid from a titration. So it tells you a little bit about compound A. It's a straight chain organic acid, and it also tells you what the chemist did. They prepared a 250 centimeter cube sample of A by dissolving 10.8 grams of it in water, and following that in a titration, 25 centimeters cubed of 0.5 mole per decimeter cubed sodium hydroxide were neutralized by exactly 21.40 centimeters cubed of solution A. They first want you to calculate the pH of the sodium hydroxide used, and then use the results to calculate the molar mass of acid A and suggest its identity. So let's look at what they've given us first of all. You need to visualize the process. You start with your solid A. I know it's a solid because they've given it to me as 10.8 grams rather than a volume of liquid. So then this is put into 250 centimeters cubed of water, and then that is titrated. So solution A is put into the burette, and in the titration 21.40 centimeters cubed of it is used, and what it's titrated against is 25 centimeters cubed of 0.5 mole per decimeter cubed NaOH. So the first thing they wanted to do in terms of calculating is to work out the pH of the sodium hydroxide. So we know that sodium hydroxide is a strong base, so therefore the concentration of sodium hydroxide will be the same as the concentration of hydroxide ions because it fully dissociates. Now working out the pH of a strong base requires us to use Kw. So you can get Kw from the data sheet. It's 1.00 times 10 to the minus 14. And the question already tells you by implication that the concentration of hydroxide ions is 0.5 moles per decimeter cubed. So we need to rearrange the equation to get H plus as the subject. So that gives us 2 times 10 to the minus 14 moles per decimeter cubed, which then goes into the pH calculation, minus log of H plus, and then that gives us 13.70. So I rounded to 2 decimal places, which is the standard number of decimal places to express pH. So now we need to use the results. So by the results, what they mean is what happened in the titration. So I'm going to put in A as my acid, and NaOH as my alkali, and I'm going to use the data moles equation moles answer technique. So the question gives me the values I need to work out the moles of sodium hydroxide, which is 0.0125 moles. Now I'm assuming that my acid A is monobasic, so therefore that must mean it reacts with an alkali like sodium hydroxide in a 1:1 mole ratio. So I'm working on the premise that H plus and OH minus react in a 1:1 mole ratio here to make water. So that must mean that the number of moles of my acid A is the same as the number of moles of sodium hydroxide, but that's in 21.40 centimeters cubed. Now the number of moles of A in the original sample is 0.0125 times the scaling factor, which is 250 divided by 21.40. So that gives me 0.146028037 moles. I'm keeping my calculator value, but I haven't reached the end of my calculation yet. So to get the MR of A, you divide its mass by the number of moles that are present in the original sample, and that gives us 74 grams per mole. So to work out the structure of A, the carboxylic acid functional group is responsible for 45 grams per mole out of the 74. So the straight chain part referred to in the question will be the difference between the two, which is 29 grams per mole, which equates to C2H5. So my structure is CH3CH2COOH, which gives me propanoic acid. Okay, hopefully this was a useful look at this kind of unstructured question. Until next time, thanks for listening and see you soon.